All right, so coordinates of a point on a circle centered at the origin. Coordinates on a point of a point on a circle. Okay, and we talked about this Friday. It says from topic 3.2, we know that cosine theta is x over r. So if I wanted to find the x coordinate, I could just multiply both sides by r. And I find that my x coordinate is located at r cosine theta, right? Well, what if I'm talking about the unit circle? What is r? 1. So it makes sense that my x value is just cosine theta. Everybody following that? Okay. Now, given this information, this is example 1. The figure shows a circle of radius 4 along with the equilateral triangle PQO. And the fact that it's equilateral should trigger some geometry thoughts. It should tell you that this circle is cut at pi over 3. Yeah. Okay. So which of the following are the coordinates of Q? So we're looking over here at Q. And I know that the radius is 4. So Q is going to be located at 4 cosine. And P is at actually pi over 3. So where's Q? At what angle?
2 pi over 3.
2 pi over 3. Good. So the x value is going to be at 4 cosine of 2 pi over 3. And your y value is going to be at 4 sine of 2 pi over 3. That's a great question. So what's the difference in C and D? And why is C right and D's not?
It's in quadrant.
Cosine of 2 pi over 3, this number right here is what? You unit circle. Negative what? Negative 1/2. Cosine of 2 pi over 3 is already negative. So I don't also have to say negative 4. Okay, so we're going to go with C on that. Good question. I was going to get there with my askins. Questions on that, anybody? Maybe? All right, move it on. All right, so this is example 2. And it says the figure above shows a circle of radius r along with the line y equals negative x. Okay, now I used a lot of intuition here. The way that they worked this out in the solution made me think, wouldn't have thought of it that way. So I'm going to walk you through my thought process, and then we'll go alternatively and see what they're thinking. It says the circle and the line y equals negative x intersect at points R and O and P. Okay? If the coordinates of P are 6 square root 2, comma, negative 6 square root 2, what is the value of R? So in other words, what's the radius? Okay? Now, this is the line y equals negative x. So at what angle does the line y equals x or the line y equals negative x, at what angle does that cross through that origin? It crosses at 45 degrees, okay? Because it's not tilted any other way. It's got a slope 1 to 1, right? And I know tangent y over x, 1 over 1, is that at increments of 45 degrees. You following that? So this value, r, is not pi over 4, but what's this one over here? R. Right here would be pi over 4. This one's 3. We skipped 2 because 2 is the up and down. 2 pi over 4 is pi over 2. So this guy is going to be 3 pi over 4. This will be 4 pi over 4, 5 pi over 4, 6 pi over 4. This one's going to be 7 pi over 4. You could do 2 pi minus pi over 4. That gives you 8 pi over 4 minus 1 pi over 4. Puts you back at 7 pi over 4, right? Okay, so here's what I did. I set my 6 square root 2, the x value for P. And I'm using this idea that x is equal to r cosine theta. You with me? And the x value for P is 6 square root 2 equal to r cosine of, where is P located?
45.
7 pi over 4?
What?
Oh, yeah. And so now I'm going to evaluate and solve for r. What is cosine of 7 pi over 4? Square root 2 over 2. Is it positive or negative?
Positive.
Positive, because it's in quadrant 4. Okay, so that's a positive square root 2 over 2. So r times square root 2 over 2 is equal to 6 square root 2. Are y'all following this? Kind of trekking? So I'm solving for r here. So how do I get rid of this square root 2 over 2? Multiply by the reciprocal. Boy, y'all know things. So multiply by that 2 square root 2, 2 over square root 2, to cancel all of that business. And I'm left with r is equal to 12. R is 12. Whoa, Pete. You could have also used the y value. But instead of setting it equal to cosine of 7 pi over 4, you would have to go with sine. So really quickly, that would be r sine of 7 pi over 4. What's the sine value at 7 pi over 4? Negative square root 2 over 2. And so you could see if I multiplied by the reciprocal, and this one's negative 6 square root 2. You can see that the negatives cancel, the square roots cancel, and I still get 12 for r. Okay. Now, this is the way that they did it on the solution. And I would have never thought of this. They said Pythagorean theorem. You thought that, really? Mm-hmm. What? They did like this. X squared plus y squared equals r squared. So if I plug in my x coordinate here, 6 square root 2 squared plus negative 6 square root 2 squared, I can end up with r squared. And that's 6 square root 2 group squared. When I square a product, I square both pieces. So 6 squared is 36. Square root of 2 squared is, so 36 times 2 plus 36 times 2, still rocking with r squared. This is a 72 plus a 72. Anybody? 72 and 72? 144. Square root it. 12 is r. Yeah, well. Yeah. Okay. I never would have thought that. Probably never. No. Because I know unit circle values. I guess if I did it, then maybe that would have been my first thought. But okay, are y'all ready to move on? Okay, really quickly, this is example 3. It says, consider the unit circle with points P, Q, R, and S labeled above. These are the quadrantal angles. Find the values of the following. So, fast. Cosine of 0. Remember, cosine is going to be your x value on the unit circle. So, 1, and then pi over 2. Cosine of pi. Cosine of 3 pi over 2. Sine of 0. 0. Sine of pi over 2. 1. Slide up to 1. Sine of negative, or sine of pi. 0. Sine of 3 pi over 2. Negative 1. Questions on that part? Berlin, is this feeling better for you today than it did for you on Friday? Okay. Bless you.
Bless you.
Yeah, no notes on this. Okay, so we're just going to read along and kind of understand what's happening here. I told you, where in other resources I feel like we skimmed, this is really in-depth, and it makes a whole lot of sense. It says a large portion of this course requires that we can find numerical values for the functions involving sine and cosine at important angle values. The angles we've been working with on the unit circle involve multiples of pi over 4, pi over 6, and then we're also going to add pi over 3. Okay? Now, we'll put together several ideas to help with this task. Consider the unit circle above with equilateral triangle inscribed inside the circle. The angle theta shown above will have a measure of pi over 6 radians. Can you see that? This triangle has theta equal to pi over 6. Can you see that on your paper? Everybody nod. Okay. We see that the y-coordinate of the p is half. We can use Pythagorean theorem to solve for the x-coordinate. I would have not taught it this way. I taught you with the equilateral. The triangles, and we did this. I think we probably did use Pythagorean, but I didn't teach it to you with the unit circle. Okay? But look at this. X squared plus y squared equals r squared. If I know that the y value there is half, and I know that r is 1, then I can solve for the x value. X is going to equal this plus or minus square root of 3/4, plus or minus square root 3 over 2. What that tells me right here, the plus or the minus, tells me that there are 2 times when the y value is half. 2 times when the y value is positive 1/2. The first one is at positive square root 3 over 2. The other one is at negative square root 3 over 2. I want you to draw this one on your paper. It happens over here at 5 pi over 6. This is located at negative square root 3 over 2, comma, positive 1/2. Do you see that they get 2 values, plus or minus square root 3 over 2? That's what it's saying. It happens twice that my output is half. It happens at pi over 6 and again at 5 pi over 6 that my output is half, positive half, up half. My y value happens to be positive. Any questions on that, y'all? Okay. This leads us to 2 important values. Cosine of pi over 6 is square root 3 over 2. Sine of pi over 6 is half. Notice that we found 2 values of x. This is what I'm saying. The other point would be at 5 pi over 6 because there were 2 outputs for that input. The Pythagorean theorem plays an important and interesting role with trig functions. Okay. Any questions on that concept? The fact that 1/2 happens twice, and so you have a reflected x value. Any questions on that? No? I'm about to make y'all stand up and sing. I will. I made my Algebra 2 class do it. Y'all don't even look. You got the bass part. Daddy sang bass, Mama sang tenor. Where are you at, Truett? Y'all ready? This is example 4. Okay, we're going to cut this circle into pi over 6s and use symmetry to find these values. So where do you think Q is going to be located? If P is at pi over 6, 5 pi over 6. Okay, so here's a thought. I have had you count pi over 6. That's 1 pi over 6. We would have 2 pi over 6, which we would call pi over 3. And then we would have 3 pi over 6, which is pi over 2, right? And then we have 4 pi over 6, and then we get to finally 5 pi over 6. The other option, besides counting forward like that in increments of pi over 6, is to go to 6 pi over 6 and backwards 1. 6 pi over 6 is pi. You can count backwards 1, and now I'm at 5 pi over 6. Using that mentality, if I go forward from 6 pi over 6, now I'm at 7 pi over 6. And S, if I go all the way to 2 pi and back 1, 12 pi over 6 minus 1 pi over 6 puts me at 11 pi over 6. Do y'all like that better? Yes or no? Okay, all right. Fill in your coordinates. Note that when I swing to the left of the y-axis, my x values come out negative. Yep. Questions here? Would you like to just finish this worksheet on your own at this point? Are y'all okay? You want to keep going? Okay. So the next one, example 5, cuts it into quarters, right? Pi over 4, where's Q located? Not 2 pi over 4. 2 pi over 4 is pi over 2. This is 3 pi over 4. And then 4 pi over 4 is pi. And then 5 pi over 4. And then S is going to be located at 7 pi over 4. And all of my pi over 4s, I heard Joseph say this when we were having our B one day. He said all of the pi over 4s are square root 2 over 2. All of them. Now you just have to know what quadrant you're in as to whether or not they're positive or negative. Good, good. Okay. This next one is example 6. They're cutting it into thirds. Thirds. Okay. On thirds, this is always 60 degrees. For me, I always think short, long. These are short longs. At pi over 4, they're medium mediums. Here is a short long. So if I go pi over 3, then my next one over is going to be 2 pi over 3, and then 3 pi over 3, and then 4 pi over 3, good. 5 pi over 3, and 6 pi over 3 takes me all the way back around. And then these are short longs. And they have you a full-blown unit circle all filled out right below it. Say, just FYI. And then on the next page, example 7, this has us find values. Find values of the following expression. Okay? And I'm going to walk through a couple of these with you, but by now we should be able to make this walk and talk. Okay? Sine of 2 pi over 3. So that's 1 pi over 3, 2 pi over 3. Sine of that, that's a tall, positive square root 3 over 2. Sine of 7 pi over 4. Negative square root 2 over 2. Thank you, Joseph. Okay. Guys, I'm going to let you finish this one. Okay. Everybody pause and look at me. Pause and look at me. I have given you your unit circle circuit. Okay. There are values on that unit circle circuit, one that are in degrees. You need to know your ratios in degrees. Okay, if I have pi over 4, that's going to be 45 degrees, right? Pi over 3 is 60 degrees. Pi over 6 is, okay, and you need to be able to make those move in quadrants. Okay, the second thing you need to be able to do the unit circle circuit is the reciprocal functions. Okay, so tangent is sine over cosine, right? Cotangent, cosine over sine. So if I need cotangent of a function, I just flip sine and cosine. You with me? Okay, cotangent is known as 1 over tangent. So it's the reciprocal of tangent, which is cosine over sine. If I have cosine, its reciprocal is secant. So secant theta is going to be found by flipping cosine. Last one. Cosecant theta is going to be found by flipping sine. It's the reciprocal of sine. So these three values, cotangent and secant and cosecant, are going to come up on that unit circle circuit. You got to know reciprocal values, okay? So if, for instance, this is 7 pi over 4, sine of 7 pi over 4. If it said cosecant of 7 pi over 4, you know sine of 7 pi over 4 is negative square root 2 over 2. So you would flip it. Probably you might have to rationalize the denominator. It could happen. So you end up with negative 2 square root 2 over 2. Those cancel. And you have cosecant of 7 pi over 4 is negative square root 2. Okay. It could happen. I'm not saying. So power to you. You can finish this worksheet right quick. It should take you less than a minute. And then work on the circuit together. The circuit's your assignment for this lesson. Okay? Hey, I didn't make you sing. It's a good day.